today, let statements. Take a second, please. The way this thing photocopied, it put a hole right in the title of the lesson. Can you see it?
Yes.
It's supposed to say let statements at the top. Yes? Let statements. Here, let me switch to that page so you can see it. Let statements. I'll get back to learning goal in a second. Let me just make sure you get that title down. I don't want to miss that. Yes. Let statements. You might have to write it over top of where the hole punch hit there. Is it good? Maybe you sort of remember let statements from previous math classes. Maybe not. But it's pretty short and easy on a Friday because I really want you to have time to do assignments because I've got some due dates coming up. I got some assignment due dates coming up. So, our learning goal for the day is to learn what a let statement is. A let statement. And we'll know we're being successful if we can write our own let statements. We're going to do the front page together, and then you do the back page on your own. I think the front page and the back page are pretty similar today. That doesn't always happen in math, but today it is. If you can do the front, you can probably do the back. Peter. Thank you. All right. Ooh, I got to change the settings here, so I'm ready to go. There, I'm ready to go. Let statements. Two different scenarios right off the hop. I know you've got a third different scenario. It's just on a separate page for me. Okay, first scenario, babysitting earnings. A family pays the babysitter $10 per hour, not bad, plus a $5 tip. So they get the $5 regardless, okay? And then it immediately jumps into let statements. Let x equal let y equals. Well, if we're going to make equations, we got to know what x is going to represent and what y is going to represent. Now, here's the two things in the question that we have to talk about. That's the big deal in the question is, what two things are we working with? Let me ask you this. If you want to know how much you're going to make, what do you need to know? What do you need to decide? What do you need to find out from this family? For sure, we're going to need that start value. We know that. Yes? We know it's going to be $5. So if I want to figure out, let's say they call you to hire you and they say, we want you to babysit Saturday. What are you going to ask? What are you going to say? What do you want to know so you can figure out how much money you're going to get? Yeah, how much time? For how long? So that is the input if you want. That's what we got to know before we can get the answer. So we usually use that as X. I shouldn't really say usually. I just know usually in the world sometimes we use X for other things. But in this math course, we use X as the input. Gentlemen. Let X equal hours worked. That's how I come up with the X. I think about it and I go, what am I going to need to find out to get the answer here? Then there's going to be an answer. Then you're going to find out something. Once I know the hours worked, I'm going to use that to find out something really important, the really important number in this question, the really important quantity. What's the quantity you want to know? If you're going to babysit this weekend, what are you going to try and find out? Once you have the hours worked. Welcome. Previous class just had a test, so the desks are all over the place. There's your sheet. Welcome. No. Last period had a test. Another class, not us. And we didn't fix the desks afterwards because it went right to lunch. So it's just all over the place. We're just going to go with it, all right? And then my class has a test last period, so I didn't want to fix them any more than I had to because I just got out and fixed them again anyway. Back to here. What do you want to know when you're babysitting? Like, what are you going to try and find out when this is all over? Peter. How much you're going to get? That's the answer to the question. That's the output. That's what you really want to find out here. So I'm going to write down let y equal how much money made. Yes. Let statements over. Let statements over. And if you want, lesson over. Now I'm just going to go back and review all the other stuff we've been doing, trying to loop back and get that stuff. Write the equation in y equals mx plus b form. What's that? The fan is on. Yes. And I'll put it on oscillate so it goes back and forth here. Ready to do the equation. Money equals y equals mx plus b. What's the rate or the slope here? How much is this going up by, Gwen? 10 is how much it's going up by. That's the rate. So we're going to take the 10 and multiply it by how many hours we work. But that's not the end. There's a start value here. There's a b. There's some money you get anyways, plus $5. That's really yesterday's lesson and the day before. I'm bringing all that back here into this particular lesson here. Making sense? Can't tell. Yes? Oh, it looked like you were, no? You don't need Kleenex? I thought you were going to sneeze there, no? All right. Oh, okay. Well, I'm ready. I'm here to help. In real life terms, what is the y-intercept? What is this 5? I hope this is the easiest question on the page. I hope it's easy to reflect back. What are we talking about with the 5? What is the $5 representing? What is that? What's that in the question? It is the y-intercept. The y-intercept in the equation. But in the real world, in the actual scenario, what does $5 represent? The tip. Maybe that question's so easy it's hard. You're like, yeah, we already talked about that. Why are you asking me again? It's like bringing it all back so you see all the way around what's going on here. And what is the real life implication of a greater y-intercept? What if your y-intercept went up in this case? What if they offered you a bigger y-intercept? What are they offering you? More money. Which kind of money? Is that more tip? Or is that more per hour? Tip. Okay. What is it? A greater y-intercept? That would be a greater tip. What if you get a smaller y-intercept? A smaller tip, yeah. Sometimes, like math questions, are like, you're scared because they seem a little easy. Yeah, these weren't supposed to be overly tough questions. Okay, in real life term, what is the slope rate? It is 10, yes. And what does that represent? In words. What are we talking about there? It's the hourly rate. Yeah, it's the hourly rate. So what if we got a steeper slope? What would that mean if I was going to pay you with a steeper slope?
A raise.
A raise. Which kind of raise, though? There's two numbers here.
A raise in the hourly rate.
A raise in the hourly rate. Perfect. Can't tell if this question's out of date or not. Haven't had to hire a babysitter for a while. Is $10 an hour? Is that pretty good babysitting rate? Or
I don't know.
nobody knows. Yeah. And what about a smaller slope? What if you had a smaller rate, Peter? A drop in hourly rate. Okay, well that's the lesson. But I'm going to do it 3 times in a row to make sure we've looked at different scenarios. All I'm going to do is do the same thing in a different scenario. Here's a new scenario. A bank account is open with a balance of $900. So let's say you go to the bank and you put your $900 in there that you made this summer. Each week, $150. So each week you take out $150 to pay for expenses and everything like that. Okay. Let X equal. Okay, if you want to know how much money is going to be in your account, what do you got to decide? What information do you need? Like if I say, well, how much money are you going to have? What is it you need to know or think about? What's the number you're going to put into this situation? 900 we're definitely going to use. I'm talking about the unknown in the situation. Something that we don't know yet about the situation that's going to tell us how much money you're going to have. Gwen? Yes, that's true. That's what we want to figure out, how much money they're going to have later on. But to figure that out, to know how much money you're going to have later on, we need some information that we don't know yet. What's the information? Yeah, okay, so how much money are you going to take out? That's exactly right. How much money are you going to take out? We're going to take out $150 per week. So what do I need to know to figure out how much money's been taken out?
The weekly withdrawal.
Yeah, like how many weeks have passed here? Yeah, if we're going to know how much money's left, we need to know how many weeks have passed. So let x equal number of weeks. Once we have the number of weeks, then we can figure out, let y equal the remaining balance. Or I'll say the remaining money. Have you used the word balance before? Do you guys use bank accounts enough or use the word balance? Balance is just how much money's in your account. But I'll write money. So, write the equation y equals mx plus b. What's the rate that the money's coming out?
Negative 150x.
Oh, he caught it. I thought he was going to catch it. I thought I was going to get to do some extra teaching. I thought he was going to say 150. But in this case, since it's going down, he caught it, negative 150. And how much is the starting value? How much is in the account at the beginning?
900.
How much?
900.
900. So in real life term, what's the y-intercept represent? What's this 900 represent as far as the situation is?
Number of weeks.
The bank account.
How much you start off with?
Yes, good, perfect. How much you start with. And so what would the implications of a greater y-intercept? What if the y-intercept was bigger?
Greater start value.
Greater start value. I'll put greater starting amount. What about a smaller y-intercept? Smaller starting amount, yeah, good. So in real life terms, what is the slope rate? So what's the rate in this question, and what does it mean in terms of the question? We're just looping back to the original thing. Negative 150, and what's that represent?
The rate, the hourly rate, the weekly rate.
Good, you got to it.
The withdrawal.
Yeah, all that. Negative 150, it's the weekly withdrawal. So I just put together everything you said there into one sentence. Withdrawal. Have you seen that word before, withdrawal?
Yes.
It means what you're taking out of the account. Yeah. And then, so if you had a steep, okay, careful now. If it was a steeper slope, what would that mean as far as what was happening to your account if it was going down at a steeper rate? This line's negative. So do you want your negative slope, the amount it's going down by, do you want that to be steeper? That's going to take more and more out of your account faster. Yeah, we don't want that. So that's more money coming out. See, steeper isn't always better, is it? I'm thinking of going skiing this winter with my kids. Is steeper better? I guess I don't know. Sometimes it's better. Sometimes I want to go faster. So I'll be happy with a steeper hill. But when I first put my kids in the hill, I don't think I want it to be steeper. How about a flatter slope? Less money coming out. One more scenario to go, but we'll go a little faster. Do you need more time here? Hold on. Let's just do this for now. Let's do this for now. Last example. A car rental. Rent a ride, charge a flat fee of $55. Actually, this is the way rental cars usually work. You go in, you pay actually, it's usually more than this, but anyways, 55 bucks, and then when you get back, they check how many kilometers you used, and they charge you based on how far you drove the car. Okay? So if you wanted to figure out how much this rental car is going to cost you total, what would you need to know beforehand? What would you need to be looking at? Yeah, let X equal number of kilometers. And once you knew the number of, gentlemen, once you knew the number of kilometers, what would you figure out? It's the important thing you want to know about renting a car. Yeah, how much is it? Total cost. So what is the equation in y equals mx plus b form? What's the rate here? What's the slope? What's it going up by all the time? 0.25. And what's the start value? What do you have to pay no matter what?
50.
55. In real life terms, what is the y-intercept?
0.25.
No.
55.
55.
Flat.
That's the flat fee. What's the real life implication of a greater y-intercept? Higher flat fee. What about a smaller y-intercept? Lower flat fee. Yeah. How about the slope? What's the real words for the slope here? It's 25 cents. And that's the price per kilometer. It's how much you got to pay for each kilometer. I'm sure they're going to charge more than that. A greater slope would mean higher rate. And a smaller slope would be lower rate. Do you have any questions? Yeah. Do you need more time? Yes, please. I like it. I've got the plan. Got a plan in mind. I'm ready. Okay. More time? All right, here we go. Here is the wrap up. Write a scenario for each given equation. This says y equals 3x plus 10. I say to write up a scenario, you better first write down what's the rate and what's the start value. Write that every time. What is the rate in this question? Also called the slope. Daniel. 3, yeah. Well, okay, it's not, the x is some number we're going to sub in. The rate is just the number 3. And what about the start value? 10. So I got to make up some scenario, as ridiculous or silly as I want. You can steal from other scenarios, yes? Because there's all scenarios. I just made up 3 scenarios in the previous page, and you could steal from there. Or you can make up your own. Can you tell me something that you can make up where something starts at 10 and it's going up by 3s? Anything you want. Starts at 10. It's going up by 3s. Do you want to use money?
Yeah.
You have one?
Yeah.
I'm excited. Will you share it with us?
Yes, I will. Oh, so like when you get your mail stuff, pay for the length. So it's like when you get like the extra long ones, it's like extra money.
Yes.
That was our idea.
Okay. Okay. So is like a flat fee at the start?
Yeah.
Okay. So let me try and put it in words. Getting your nails done. Is $10 plus $3 per extra. I don't know if this is accurate or not. I don't know how long a nail you get, but I'll say per extra centimeter that you put on or something like that. Is that exactly how they charge? No, but we're trying to use a scenario we know to put into here. So it's okay that we don't match exactly what the nail salon charges. Emma. What's that? No, I haven't done the let statements yet. It says write a scenario, so I wrote a scenario. And in a second, I'll do the let statements. This is just beside your equation. Okay, that was good. Thank you for sharing that. Let's see if somebody else wants to share. The rate for this one and the start value. And I'm going to ask you again, hopefully to keep bringing more of you online here where you can just look at it. We want to get to the point where we can just look at it and bang, we know the rate, we know the start value, and then we can talk about what the scenario is. I don't know why I say a scenario like that. That silent C just annoys me. So I just say scenario to remind myself how to say it. It's scenario. So what would the rate in this question be? 20, yeah. And what would the start value be? 100. So now a scenario. Some situation. Let's try and be a little creative and not use fingernails again.
Oh no, just the nails, not skin.
Oh, yeah, let's not use fingernails again. Well, let's try and come up with something new, a new scenario, something that starts at 100 and goes up by 20. Okay, tell me. Yeah, and each week grows by 20. Perfect. Your hair length starts at 100 centimeters. Is that long for hair? I guess it would be, wouldn't it? Here's 100 centimeters. Let me see. Wouldn't that, how would I look with 100 centimeter hair?
You'd be able to easily get caught it, catch it in something.
You know what? I've seen people with maybe that long of hair before. Yeah? Goes down that far before? Yeah. Some of you might actually be somewhat close to that. That'd be hard to manage. Yeah, but your hair length starts at 100 centimeter and grows at 20 centimeters. Could it grow 20 centimeters in a week? Maybe a month. No, probably not even a month. But we don't have to be perfectly realistic here. We can play a little bit here. 20 centimeters per month.
It only has to be semi-real.
Yeah, we sort of trying to make it real, but not really. Yeah, we're not getting too crazy here. So what were the let statements? Okay, let's look at the first one then. If you wanted to know how much your nails are going to cost, you're deciding, I'm going in on Wednesday for my nail appointment. You're deciding how much money do I got to take. What do you got to know beforehand? What's the input? Daniel. What's that? Yes. What do you got to know beforehand? Before you go to your nail appointment, you got to decide how much money you're going to take. What's the big decision you got to make? Yeah. So I'm going to go let X be length of nails. That's what I need to know before I even start, before I go to my appointment. So then let Y be, well, Y is what I'm going to figure out. Once I know my length of nails, I'm going to use that to find out what? What is it you really want to know before you go to get your nails done?
How much it's going to cost?
How much it costs? What Y be? Total cost. And you'll see total cost, lots of situations. What we're talking about is total cost. That's what we really want to know. Okay, second situation. Let X be. Well, if you want to find out your hair length, you're going to need some information. Say, well, when will my hair length be this? Say you're getting ready for a wedding, or say you're getting ready to get your hair cut or something. What do you got to know about the situation to be able to decide how long your hair is going to be then? What's the unknown here? I want to know my hair length. What am I going to have to use to find out what my hair length is going to be? What's that? For sure you would use a ruler to measure it. But if you were going to predict it, if you're going to say, oh, my hair is going to be this length after this much time, I need to know how much time has passed. Yeah? So let X be number of months. Once I have that, then you'll know, you'll be able to use that to get the hair length. So in summary, let X equal the input variable, sometimes called independent, and let Y equal the output. Sometimes called dependent. Have you heard those words before? Independent and dependent. Independent's what I plug in, dependent's what I get out. Ava. Yeah. All right, that's it. That's all for today. 10 to 1, we're already done. On the back, you got to make some let statements and some equations, and then you get a chance to write 4 scenarios at the end.